Welcome back to the stream, folks. Oh, Tuco's just so cute right now. I think he wants to share the seat again. Space. Whoa. That was certainly some feedback. Hello, welcome back to the stream. I've been fussing after Tuco's food a bunch. I still don't think he's eating enough, but I'm trying to make sure he eats as much as he wants. He just ate some more of that. Oh, you've got some good purrs here. I wonder if I can make the purrs louder. Where to? Oh, you want that open? Okay. We can do a little bit of that. It's cold out there, honey. Gosh, I'm gonna close that in just a sec because my housemate has the heater on. Tuco and them have very different ideas about what temperatures are good. Oh yeah, he just thoroughly wants to investigate whatever's going on out there. Hey, Tuco. It sounds like a ground loop, doesn't it? I'm pretty sure it's actually coming through the air and not through the wire at this point. I've been meaning to debug that actually because it sounds a lot like the microphone here is just acting like a big old electromagnetic pickup. But I thought it was actually in a grounded metal cage, so maybe there's a grounding fault. But I mean, a big part of the problem is just that these mics have a really high gain preamp on them, and a bunch of the stuff in here just puts out loads of electromagnetic interference. Hey, Tuco. That's the same kind of mic as this. It's just right now you're listening to it through a fancy chain of filters that's trying to get rid of as much of that as it can. Tuco. Tuco, don't step on any of that, boy. Oh, you like that? Are you gonna bite the webcam? Hey, Tuco, don't stand on that. Don't stand on that. Hey, can I pick you up? Okay, boy. So I should mention what's going on with this cursed bootloader zone. So I have adjusted my priorities for this machine, this project where I'm getting Linux to run on the old voting machine. I had a few sort of complicated things I was trying to get working, and right now my priority is I want to be able to put this thing away and be able to like use my desk for other things. And I would want to be able to have something on the compact flash card that is pretty reliable, and I would want to be able to have I guess the issue is it has these two PCMCIA slots which are easy to access when the machine's fully assembled, but if I actually if I have the cover fully on, the compact flash card slot that it actually boots off of is not the easiest to access. It's not completely, it's not secured, I guess I should say. You basically have to take off some screws and take the bottom half of the machine apart, and then you get access to the motherboard, including the CF card. So I could take advantage of that relative ease of access and just take it the rest of the way and actually just cut a door in the bottom of the machine. That might be a prudent thing to do. The thing that I was trying to get working partly was to have a network boot system where I would have a small Linux user space that would set up PCMCIA, and I'm distracted too good with these headphones. I was trying to use these little earbuds because they stay out of the picture, but they then apparently they don't stay out of the audio. Too much feedback. Do you want to share that? So yeah, I want something I can put on this internal compact flash card that is pretty unobtrusive, that is pretty reliable, and then I can use to boot other things. I don't have to change this too much. It would be very convenient if I could just have it boot off of one of the removable cards. I suppose one way to go about that actually is that there is a mode this motherboard supposedly has where it can boot with one of the compact flash or one of the PCMCIA slots substituted in place of the BIOS, which seems like a fabulous debugging option that you can just stick a card in there and that's your new BIOS. The BIOS address space is large enough that we could probably even, I don't know if we could stick grub in there maybe. That would be interesting. Tuco, if you're done with that door, maybe I should close it. It's getting cold in here. We're letting all that warm air out. Maybe we should get Tuco back on the mic. Yeah, so it's kind of frustrating because I want something that's pretty simple so that it can be low maintenance, but then I need to get the PCMCIA slots working to get access to any peripherals with storage space to them. I can do that on Linux, but it's not the simplest, and it seems to involve some user space components. So yeah, I did a quick Twitter poll on this actually. Pull it up. Do we have Tuco prying on here? Yeah. Oh, Tuco, you getting up? Oh, good, he's eating. So yeah, I totally didn't explain what I was actually doing here, but the options I presented was to make grub do it or make kexec do it. The make grub do it option is to try to make grub flexible enough that it can boot off of the PC card slots somehow. And then I can put the machine back together with that version of grub sealed inside basically, and then swap out the cards to have this thing do whatever I want. I could put a kernel on the PCMCIA card slot and then have it boot over the network, or put the whole thing on the PC card slot. This one feels relatively realistic of an option, and it would be overall fairly simple and reliable. So Grub doesn't itself have PCMCIA support. So there are also two major code bases for Grub. There are two branches of development. There was the legacy branch, or like Grub 0.9, and then there's the like actually modern Grub, which is Grub 2. I think the version numbers are in the low 2s. There was some other project I'm forgetting where it was called 2, but the version numbers actually approach 2 rather than starting at 2. Man, people just choose the weirdest version schemes for open source software sometimes, which is not always bad. It's just confusing. Yeah, anyway, there are these two major code bases. The old Grub actually did have some support for network devices. Like, it doesn't support this exact network card because it didn't support PCMCIA network cards, but it did support some of the 3COM 3C509 family cards. So with some work, it seems possible to hack on a driver to get the old Grub to support both the particular PCMCIA controller that this uses, which is a slightly non-standard variant of the Intel 82365 chipset, which is built into this AMD SC400 chip that this board runs. So one option would be to hack on the old Grub to get it to work with this card, given that it supports some similar cards. And then I could have network boot, which would be very useful. The new Grub also supports network boot, but via a completely different mechanism. It doesn't have its own drivers. Instead, it completely just relies on the PXE boot standard, or PXE boot. That's not super useful for us. Like, these PCMCIA network cards never supported PXE boot. It just wasn't a thing. The other similar network cards of the era didn't often support network boot on their own, but it was common for like ISA network cards to have a socket where you could burn a ROM chip, like a literal EEPROM, with some bootloader that you wanted, and then just stick that in the network card, and then that would appear in the address space where the BIOS would find it and then run it during boot. So now you'd have like a, I mean, I think the range of, I don't actually know what the commercial cards at the time offered because I never had any of those, but like I remember getting an old like 3COM card or something and then burning an EEPROM with this open source project EtherBoot. And so EtherBoot at least would just directly support stuff like DHCP and TFTP. But anyway, I think part of the problem was that a bunch of different network card vendors just did their own thing here, and so PXE or PXE came along to try to standardize that. So Grub, the new version of Grub requires that. It does all of its networking through PXE, so that's not useful here unless we want to write like an entire PXE driver for this network card. So if we want it to network boot, really the main option for that is to use Linux, unless we want to go about like writing or heavily modifying drivers. And so the way to do that would be something like boot into a very small Linux kernel that has just enough for us to get the network up and PCMCIA up. And then just to make this first kernel as much like a bootloader as possible and leave as much flexibility in the configuration of another kernel, we could have that first kernel built with kexec support so that it can just download whatever from the network and kexec it. And then I can, I'm imagining that if I actually want this machine to be configurable to do different things as a kind of silly object, like a prop for videos or whatever, then I could imagine just having it on the network. But I could also imagine just taking a network card and a Raspberry Pi and connecting them in some manner, either with a dongle like this, or it turns out that these network cards are actually really inexpensive if you don't need the dongle that connects it to Ethernet. So if I reverse engineer the pinout of the one dongle I have, it turns out I've got a second card because they were really cheap on eBay. I could modify that second card to just wire directly to a Raspberry Pi without the dongle, which is the unobtainium, well, not unobtainium, but significantly more expensive piece in these old network adapters. So then I could basically just have something that's a PCMCIA shaped Raspberry Pi that gives this thing a somewhat more modern storage and link to the outside world without exposing it directly to the local network. And then I could have a small kernel image that loads off the compact flash card, all read-only, that just sets up a static IP address on that network adapter, pulls over whatever kernel image and boot file system it wants from the Raspberry Pi, and then we go from there. And then I can like SCP boot images to the Raspberry and have various of them available, and that might actually be a fairly convenient kind of weird retro computing-ish setup for this old voting machine. So that's one route to go. Basically the minimal Linux kernel plus network boot plus kexec route. And that's complicated compared to, I think, the alternatives, maybe. It's not that complicated. It's a lot of the same debugging that we're going to need anyway, because I need to get Linux to work with these PCMCIA devices later anyway, so I can use the exact same patches and build scripts for this loader and just debug it until the loader works, and then use the loader to load whatever else I want. So yeah, it doesn't seem really all that complicated. It is complicated in the sense that a large amount of software would end up getting included in that boot image. So it would be relatively long in terms of boot sequence, and there would be a lot of places for hidden bugs to be, where I might end up having to take this thing apart and reflash the card later. So that's one option, the kexec network boot strategy. That's one of the cursed bootloaders. The other cursed bootloader is continue modifying grub. This has already got a slightly modified grub on it, but modify grub further so that we can actually have grub boot directly off the PCMCIA storage device. And I think this would be relatively easy to do. So unlike the network device, where either we use the old grub and do surgery on a 3C509 driver to get it to work with the 3C589, which doesn't sound super fun. I don't know. We could make it fun, but I don't know if I want to go there. We could do surgery on a 3C509 driver, or we could do some kind of weird pixie boot thing with grub 2. Yeah, neither of those sound great. So like if I want network boot at all, it seems like Linux is probably the way to do that. So then kexec. The simplicity of the grub strategy is kind of nice. Like, I was looking at the driver earlier. I don't think we'll be able to do it with merely a grub config script. I think it will require a little bit of source patching, but not much. I think we'll basically need a grub script and/or source patch that knows how to set up the PCMCIA controller and map some IO registers. But I could probably even map the PC card to one of the traditional set of IO registers that's usually used by IDE devices, and grub might just recognize it there. I was also realizing that there's completely different code paths there for PCI machines and non-PCI machines, and I don't even know if the grub we're using knows that this machine doesn't have PCI. I'm getting vibes like I should shut up about the computing and just film the cat. Tuka, you want to leave? We totally have the computer underneath the green screen in the setup. I guess there's also the wild card of just do something totally different with this. Like, I was searching for drivers, like searching for info about Linux 3C589 stuff, I think. And I just happened upon some man pages for Plan 9. Apparently Plan 9 has drivers for this PCMCIA card. So we could try booting Plan 9 on this and just see how far that goes. That would be weird. And that's an interesting suggestion from chat, U-boot. I've never even tried U-boot on x86. I'm kind of curious what the status of that is. Oh, hey Tuco, sneeze? Should fix the layering on that video. I'm gonna actually have to mask that separately. Tuco, do you want to leave? To go ahead and use the bathroom. U-boot as a BIOS replacement. That's interesting. Yeah, I mean, that is... So I guess besides the grub strategy and the kexec strategy, there is the actual BIOS replacement strategy, which could involve trying to figure out whether the chipset feature that allows you to run the BIOS off the PCMCIA card was actually implemented on this board and how you enable it on this board. Wow, you can use U-boot to run cBIOS? That's interesting. Right, kexec would be kind of interesting because we could load ELF files over the network. So we could load additional copies of grub. We could try loading cBIOS as an ELF file. I'm pretty sure there's a way we could package up DOS and load it through kexec also. I didn't see an exact document for this, but I think the same, I forget what it's called. There's like a RAM disk kind of thing that emulates a disk at the BIOS level. Then you can load DOS via that. Like this RAM disk emulator, I forget what this thing's called. I think it's made by the SysLinux guy. Memdisk. Yeah. I bet you could run this via kexec and then use it to load DOS. So if we had a way of pulling network files over and then kexecing those, that'd be kind of cool. All right. What's our goal for tonight then? No, Tucon's back in. Hey. Leave you off the seat. Hey. Hey. Love you. My inclination at this point with the bootloader thing is why not both? Like we could have a kernel on the SD card that supports kexec and then use that if we want, but also just have a kernel there and have Linux. And I'm getting the impression, I know these are like famous last words or whatever the tech people say, but like I get the impression that it's not necessarily going to be that difficult to get Grub to interact with the PCMCIA hard disk. Yeah, that's an interesting point. We could also just add an option ROM on the PC104 bus somewhere. That would require buying or building some hardware, something that has a ROM socket. It is a shame that PCMCIA network cards don't have that ROM socket like ISA network cards did. So actually, I got a second one of these network cards in the mail. It would be interesting to take the cover off of it and see what it does have in it. Maybe that's the thing we could do tonight. Hmm. Oh, he's purring pretty loud. I gotta get the cat mic again. This is your ear itch too. I need to find an EQ plugin for this that sucks less. This one has like the worst EQ UI I've seen in a while. Probably use the chipset's memory mapping windows to stick my own code in the ROM regions. I wonder, like, I haven't checked to see whether the BIOS actually clears those memory mapping regions. It doesn't seem like it uses them for anything. Oh, that's funny. Not EEPROM socket just soldered to the back of an ISA slot on the motherboard. That does seem like one approach. I don't know if that would super help though. I mean, I guess I could add a way to, like, part of the problem I'm trying to solve is that I want to be able to put the lid back on this machine, right? That seems like it's getting me another thing to debug that requires having access to the whole motherboard. Yeah, okay, so one argument for modifying the BIOS is that I could change the disk geometry table. That seems pretty low risk. Pretty useful. Before I do that, though, I should actually investigate in more detail why the BIOS even seemed cranky with these larger disks. Since I didn't investigate this much, but the small amount of investigation I did do seemed to show that the BIOS was giving up really early on the 128 meg and the gigabyte disks that I tried it on. But like a larger disk in the CF slot is actually not as useful as a disk in the PCMCIA slot, because that one requires disassembling the machine to get to. Click, click, click. So I kind of like the idea of just ignoring the BIOS as much as possible, having some sort of bootloader on the CF card, and then removable media and or network for the rest of it. So we can look at what the driver is doing, or look at the data sheets for details on how to actually get Grub to talk to the PCMCIA disk. I think it mostly just involves writing to a couple of registers on the PC card controller to turn on the card and to map its I/O resources. I think we can ignore the memory resources for the hard disk. I also think we can ignore the interrupt, but gotta check on that. Are we discharging static onto the microphone? Yeah. That clicking is definitely static electricity. Some of those I can hear it crackle at the same time I can feel it crackle. Tuco, you're so sparkly with energy. Oh. Tuco. Stream. Oh yeah, maybe we'll just make... Sorry, that isn't coming through very well. Maybe we'll actually just make this kind of a short cat stream. Hanging out with Toot feels like the most important thing right now. But yeah, if you're interested in the cursed bootloader and you're on Twitter, vote in the cursed bootloader poll if you make it in time. If you wanna direct me toward kexec or grub for this cursed endeavor. Either way, it'll be nice to actually put the voting machine back together. Good morning. We have a good morning in chat. Hey, good morning. It's pretty late here, but it's always morning somewhere. And you found that place. Here we have a cat and potential for cursed bootloaders. Ear noises. Alright, well that's all I got tonight, but we will conclude this cursed bootloader business tomorrow, I think. Have a good night, folks.